We're looking at solving exponential equations. The first method we're going to look at is equating the bases. So when you look at the problem, are the bases of each exponent powers of the same number? In this case, we have 5 and 1 over 125. And we should know that 1 over 125 is equal to 5 to negative 3 power. So we now have the equation 5 to the 2x minus 3 is equal to 5 to the negative 3. And if we have two exponents or powers with the same base that are equal to each other, then our exponents have to be equal. So we can solve the equation 2x minus 3 is equal to negative 3. I can add 3. 2x is equal to 0, so x is equal to 0. Let's do another one. 100 to the x equals 1 over 10 to the x minus 3. Well, 10 and 1/10 are both powers of 10. So 100 is 10 squared to the x power, and 1/10 is 10 to the negative 1 to the x minus 3. Now I have 10 to the 2x equals 10 to the negative x plus 3. Don't forget to distribute that negative when I multiply it out. When we have a power to a power, we multiply our exponents. Now my bases are the same, so the exponents must be equal to each other. So 2x has to equal negative x plus 3. Add x to both sides, and 3x equals 3, so x is equal to 1. Now, if we don't have the same bases, we can rewrite the equation as a log in order to solve it. So we have, say, 3 to the x is equal to 10. Well, I can't write 10 as a power of 3, so I have to try rewriting it as a log. So let's remember that if I have the log, that's not right. If I have 3 to the second power equals 9, this written as a log is log base 3 of 9 equals 2. My exponent becomes what it's equal to, and what it's equal to goes inside the log, and my basis of the log is the base of the exponent. So to rewrite this equation, 3 to the x equals 10, as a logarithm, it's log base 3. What it's equal to goes inside the log, and the exponent is what the log is equal to. So log base 3 of 10 is equal to x. Our change base formula tells us in the calculator, I can do log of 10, log of the number inside the log divided by the log of 3. Now some calculators will actually do the log base 3 of 10. That can actually be done in Desmos if you use that calculator app, but a lot of calculators only do log base 10, and so you have to use the change of base formula, and when we do that, we get 2.096. So I generally say round to the thousandths place when you're doing logarithms. All right, let's look at a different one, maybe that has a coefficient. 4 times 2 to the x equals, let's pick a big number, 15,000. This is kind of like the zombie problems we talked about. We have 4 zombies to start with, and each one infects one person a day. How long will it take to have 15,000 zombies? So we would have to first get the exponential term by itself before we can rewrite the log. So I'm going to divide by 4. And 2 to the x is equal to 3750. Now I can rewrite this log, or this exponent as a log. So it's log base 2, base of the exponent is the same as the base of the log, of what it's equal to, 3750 equals x. And then again, we're doing this in a calculator. If our calculator doesn't do log base 2, we have to use the change of base formula. Log of 3750 divided by the log of the base, and that equals 11.873. So if we were talking about this in context of a zombie apocalypse type problem, it would only take 11.87 days to have 15,000 zombies. if you started with 4 and they were infecting 1 per day, so the growth factor is 2. Now there's another method we're going to look at, and that is taking the log of both sides, and you'll see that you end up with the same type of equation. So another method of solving exponential equations is taking the log of both sides. You end up with the same problem as if you were to rewrite it as a log. So let's look at one. Say 2 to the x equals 9. So this says when we had the square, we could take the square root of both sides. When we had the cube, we could take the cube root of both sides. So if we have an exponential function, we can take the log of both sides. And we end up with the log of 2 to the x equals the log of 9. And we have to know our power property here. Our power property says the x can become our coefficient. We end up with x log 2 equals log of 9. To get x by itself, we divide by the log of 2. And notice we end up with the same thing. We use a change of base formula. When we rewrote this one as the log base 2 of 9 equals x, we end up with doing the same step at the end. So x is equal to 3.17. It's a 1699, so it's going to round up to 0.17.